What is up, YouTube? Mr. Keen coming out live from the studio. Here is the first thing I want you to do. I have a science experiment for you. I want you to watch this video and try and stare in the center of the screen. Okay? I want you to stare at it. Try and focus on the color. Here's your task. You need to figure out which color is the hardest for you to focus on. Which one's the hardest one or strains your eyes the most, or which one's just the one that is hard to focus on. Okay? So please watch. We're going to watch it cycle through. But I want you to notice which color is the hardest to focus on while we go through it. Okay? There is an answer I'm looking for, but I want to see if this works. It did for a lot of my students today, but some of them it didn't. Some of the colors should be easier to look at. Okay? Most students fall in two different camps. They either found that the really bright colors, the yellow, was really hard to stare at. For me personally, it was the blue or the purple for me. Those are the ones that are hardest for me to look at. And there's a reason, which you will learn at the end of the video. Okay? So in your notes, could you write light wave notes? On the left side, could you have the words? And on the right side, could you draw a picture? Okay? So the essential question for the day, why are some colors in the rainbow harder to stare at? Okay? Some of them are easier, some of them are harder. It's supposed to be the colors in the end of the rainbow, the blue and the purples. Okay? And you may have noticed a lot of companies, they won't choose those colors for their company logos. That's why like McDonald's and a lot of fast food, they have a lot of the red, orange, yellow, and green because those are warmer colors. Those are easier to look at. We're going to go over why. Okay. First thing I need you to know is wavelength. Wavelength is the distance between two crests of a wave. So a crest is the same thing as a peak. If we have a wave here, the wavelength is just the distance from here to here. That is the wavelength. So from this crest to this crest. That's the wavelength. And we use the Greek symbol lambda for wavelength. Mr. Keen, why don't we use W? Oh, good question. Yeah, it's because W was already taken. I think it was taken by watts, the electricity. So they just thought, like, why not an upside down Y? Let's use lambda in the Greek alphabet. So that's what we use for wavelength. Okay, you need to know that for what we're going to do next. Pop quiz. Pause the video now, try and think. What is the fastest thing in the universe that we know of? Okay? A lot of people answered it right. It is the speed of light. The speed of light is calculated by the wavelength of the light times the frequency. Or C equals lambda times F. Remember that lambda is wavelength. We just learned that. Instead of S for speed of light, S was taken by seconds. So physicists use C. So C is the speed of light, and that's equal to the wavelength. Frequency, the F wasn't taken, so they keep the F for frequency. So the speed of light equals the wavelength of light times its frequency. And if you don't remember from the last video, frequency is the number of waves within a second. That's what frequency is, and we use the units hertz. Okay? Next, here's your job. You need to calculate the speed of light. Hint, the wavelength of purple light is 400 times 10 to the power of negative 9 meters. And the frequency is 7.5 times 10 to the power of 14 hertz. So it could be tricky. A lot of students really struggled because these numbers are huge and they're in scientific notation. I will help you in a sec. Please pause the video now and try and calculate the speed of light yourself. Okay? Next, here's how I do it. I go to online calculator Okay. The wavelength, speed of light is wavelength, which was 400 times 10. And then you look for this arrowhead on your keyboard. I can show you. I think it's called a caret. Yes, it looks like this. I spelled it wrong, but they got it. So this, you look for this on your calculator or your keyboard. Okay. For my keyboard, it's second shift 6, and that'll get me to the power of 400 times 10 to the power of negative 9. E negative 7 means times 10 to the power of negative 7. 4 times 10 to the power of negative 7 times the frequency. And the frequency was 7.5 times 10 to the power of 14. That is the speed of light. It is a big number. That's how you get it. So the speed of light is 300 million meters per second. Incredibly fast. You know, once you turn the light on, it's getting there to the rest of the room, lickety split. All right. So what does that mean? That means every second light travels, it's covering 300 million meters. If you're curious, what is the distance around the Earth? Meters. So the distance around the Earth is 40 million meters. So light could cover the entire circumference of Earth with less than a second. Pretty crazy. Okay? And if you've seen The Flash, then you know the answer to this question. What do physicists think will happen if you go faster than the speed of light? The theory of relativity says that if you go faster than the speed of light and you survive, you go back in time. That is how some of the Flash episodes or movies work. He'll go back in time by going faster than the speed of light. We don't know how to do it yet, and maybe we never will. Next. Okay, I have a practice problem for you. Okay, so remember, speed of light is equal to wavelength times frequency. If you use algebra to rearrange the question, we now get wavelength equals the speed of light divided by frequency. How I did that, I just divided both sides by frequency to get wavelength by itself. So here's one question for you. What is the wavelength of the light if the frequency of the light wave is 4.62 times 10 to the power of 14 hertz? Please pause in the video now and try and answer. My hint is we always know what C is. The speed of light is always the same. It's always 300 million meters per second, or 3 times 10 to the power of 8. Okay, please pause the video now and try and answer. Okay. When I do it, you need to make sure you have parentheses. If you got it right, your answer should be really small. Light has really small waves, so your answer should be really small for this one. I'm going to use this formula. I'm going to start with 3 times 10 to the power of 8 divided by frequency. And the frequency was 4.62 times 10 to the power of 14. Okay. The E in the calculator, that means times 10 to the power of. So the answer is 6.49 times 10 to the power of negative 7. They can't fit all that on the calculator, so they just use E. But E represents times 10 to the power of. So the answer is 6.49 times 10 to the power of negative 7. That is the answer for this one. And I showed the work here. Please pause the video now if you want to answer it, or if you want to write it down, how I got it. here's the last practice problem. Okay. So, please write in your notes, if you rearrange the formula, wavelength equals speed of light divided by frequency, and frequency equals the speed of light divided by wavelength. Okay? Next, what is a frequency now? The frequency is going to be really big. A lot of waves happen in a second. So the frequency is going to be really big. What is the frequency of the light if the wavelength is 600 times 10 to the power of -9 meters? What is the frequency now? Hint, we always know C. So we're just solving for F. We always know what the speed of light is. Okay. Please pause the video now and try and solve it. How you do it? First step. 3 times 10 to the power of 8, the speed of light. Next, divided by, get it outside the parentheses, divided by, parentheses, 4.62. Nope. Divided by 600 times 10 to the power of -9. Times 10 to the power of -9. Okay, that is the answer. It is 5 times 10 to the power of 14. So how you put it in the calculator? Frequency is the speed of light divided by the frequency. Frequency is the speed of light divided by the wavelength, and you get a really big number. 5 times 10 to the power of 14 hertz. Okay, so that's how you solve it. If you made some mistakes on the calculator, my hint, always check that you have these formulas in parentheses. The reason is because of order of operations. Sometimes the calculator will do a step first, and your number might be too big or too small. So just to be safe, I like to put the ones with the times 10 to the power of in parentheses. Okay, we're almost done. Thank you for watching this far. You need to know different colors have different wavelengths. That's why we do it. Problem 1, you got the wavelength to be 649 nanometers, or 649 times 10 to the power of -9. If this is the visible light spectrum, what color should the light have been? If 400 nanometers is purple, 700 is red, about what color would 649 be? Hopefully you notice it's right in the middle, so it'll be like red or blood orange. Okay, that's a sneak peek for tomorrow. Since different colors have different wavelengths, therefore, the shorter wavelengths, the ones over here, they have a higher frequency. Since they have shorter wavelengths, they have more space to have more waves. Since there's a higher frequency, they'll have more energy. And so some of the colors will have more energy, and that's why purple and blue are harder to look at, because it's more energy than your eyes can handle compared to the red and orange and yellow. So the blue, indigo, and violet, those are a little bit harder to focus on because those wavelengths are shorter, so they have more frequency, so they have more energy. So it's more for your eyes to handle. And that's why it can be harder to focus on purple and blue. And that's why a lot of companies avoid those colors when they're making their brand logos. Okay, that was the last thing. In your notes, please explain why are some colors in the rainbow harder to stare at, and what did you learn today? Thank you so much, everyone, for staying with me. I know that was a long one. I appreciate it. Have a great night. Bye.